This is SpaceTime Series 27, Episode 24, for broadcast on the 23rd of February 2024. Coming up on SpaceTime, the black hole warping SpaceTime at the centre of the Milky Way. A nuclear fusion reactor sets a new world power record. And Australia's Arnhem Space Centre shows off its new vehicle assembly building designs. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has found that Sagittarius A star, the supermassive black hole at the centre of our Milky Way galaxy, is spinning so fast it's quite literally warping the space-time surrounding it into the shape of a rugby football. The new findings, reported in the monthly notices of the Royal Astronomical Society, are based on new observations by NASA's Chandra X-ray Space Telescope and the National Science Foundation's Very Large Array Radio Telescope in New Mexico. Sagittarius A star is located some 27,000 light-years away. It marks the centre of our Milky Way galaxy, and it contains as much mass as 4.3 million suns. Black holes are often described as places of infinite density in zero volume. Because of this, astronomers only know of two fundamental properties that they possess: their mass and their spin. In other words, how big they are and how quickly they rotate. And determining either of these two values tells us a lot about a black hole and its behaviour. Now, astronomers have used a new method based on X-ray and radio observations to determine how quickly Sagittarius A star is spinning based on how material is flowing towards and away from the black hole. See, material doesn't fall straight into a black hole. It first forms an accretion disk around the black hole, where it's pummeled and stretched and crushed and squeezed, eventually passing a point of no return called the event horizon. Once beyond this event horizon, material falls forever into the black hole singularity. That's because the gravitational pull of the black hole means escape velocity would exceed the speed of light, and since nothing can travel faster than the speed of light, nothing, not even light, can escape a black hole. Hence the name. The new data shows that Sagittarius A star is spinning with an angular velocity, that is the number of revolutions per second, that's about 60% the maximum possible value limit. That's the limit set by material not being able to travel faster than the speed of light. In the past, astronomers have made several estimates of Sagittarius A star's rotational speed using different techniques, and the results have been quite varied, ranging from it's not spinning at all to it's spinning almost at the speed of light. This study's lead author, Ruth Daly from Penn State University, says the new findings may help settle the ongoing question of how fast the galaxy's supermassive black hole is spinning, because the results indicate that it is spinning very rapidly, which is very interesting because it has far-reaching implications. You see, a rotating black hole pulls space-time and nearby matter around with it as it spins. It's a process called frame dragging. And the space-time around the spinning black hole is also squashed down. Looking down on a black hole from above along the barrel of any jets it produces, space-time would appear to be circular in shape. But looking at the spinning black hole from the side, space-time will be shaped more like a rugby football, and the faster the spin, the flatter the football. A black hole's spin also acts as an important source of energy. Spinning supermassive black holes can produce collimated outflows, that is, narrow beams of material such as jets or quasars, when their spin energy is extracted. But this requires that there should be at least some matter in the vicinity of the black hole. Now, because of the very limited fuel surrounding Sagittarius A star, our particular supermassive black hole at the centre of the galaxy has always been relatively quiet, at least in recent millennia, with relatively weak jets as a result. This new study, however, shows that this situation could change if the amount of material in the vicinity of the black hole increases. What it means is that in future, if the properties of the matter and the magnetic field strength close to the black hole change, part of the enormous energy the black hole spin could drive far more powerful outflows. Now, this source of material could come from gas or stars, and there are both orbiting close to the black hole. Jets powered and collimated by a galaxy-spinning black hole can profoundly affect the gas supply for the entire galaxy, and that would affect how quickly stars can form. The right amount of quasar blast could cause molecular gas and dust clouds to collapse, forming new stars. But quasars that are too powerful could blast gas out of the galaxy, thereby robbing the Milky Way of the material it needs to form new stars. And the Fermi bubbles seen in X-rays and gamma rays around the Milky Way's black hole shows that Sagittarius A star has been very active in the past. To determine the spin of Sagittarius A star, the authors used an empirically based theoretical model referred to as the outflow method. It details the relationship between the spin of the black hole and its mass, the properties of matter near the black hole, and the outflow properties. The collimated outflow produces the radio waves, while the disk of gas surrounding the black hole is responsible for the X-ray emissions. Using this method, the authors combined data from Chandra and the VLA with an independent estimate of the black hole's mass from other telescopes to constrain the black hole's spin. Although it's quiet right now, this work shows that in the future, Sagittarius A star will give an incredibly powerful kick to surrounding material. Now, this could happen in 1,000 or 1,000,000 years from now, or it could happen tomorrow. This is SpaceTime. Still to come, a new world record for nuclear fusion power, and NASA to demonstrate a new autonomous navigation system on the moon. All that and more still to come on SpaceTime. Physicists in Britain have smashed the world record for energy output using a nuclear fusion reactor, bringing us a step closer to unlimited clean energy. The experiment at the Joint European Torus, or JET, which is one of the world's largest and most powerful fusion reactors, fused heavy isotopes of hydrogen, called deuterium and tritium, to produce helium, together with vast amounts of energy. In what was JET's final deuterium-tritium experiments, high fusion power was consistently produced for 5 seconds, resulting in a groundbreaking record of 69 megajoules using a mere 0.2 milligrams of fuel. Nuclear fusion is the same process that powers the sun. Scientists see it as a clean, limitless method of energy production out of seawater that will ultimately put an end to global warming and climate change. See, current nuclear power stations use nuclear fission, in which uranium atoms are split apart, releasing tremendous amounts of energy that heats water and makes steam, and that spins turbines to generate electricity. Right now, more than 10% of the world's electricity is currently produced by nuclear power plants. Unlike fission, which releases radioactive waste as a byproduct, nuclear fusion is clean and limitless. And it's widely considered to be inherently safe, since the process isn't based on a chain reaction, as is the case with nuclear fission. JET is a tokamak, a design which uses powerful magnetic fields to confine a plasma inside a donut-shaped reactor called a torus. Beyond setting new records for power production, the experiment also achieved things never done before, deepening science's understanding of fusion physics. It demonstrated how to soften the intense heat flowing from plasma to the exhaust, and it showed how you can get the plasma edge into a stable state, preventing bursts of energy from reaching the wall. Both these techniques are intended to protect the integrity of the walls of future machines, and it's the first time that scientists have been able to test these scenarios in a deuterium-tritium environment. This is SpaceTime. Still to come, NASA to demonstrate autonomous navigation systems on the moon. And Equatorial Launch Australia has released the final designs of its new horizontal vehicle assembly buildings, which will be built at the new Arnhem Space Centre east of Darwin. All that and more still to come on SpaceTime. NASA is planning to test a new navigation system that will fundamentally change how humans, rovers and spacecraft independently track their precise location on the moon and in cislunar space. Demonstrating autonomous navigation, the Lunar Node 1 experiment is a radio beacon designed to support precise geolocation and navigation observations for landers, surface infrastructure and astronauts, digitally confirming their position on the Moon relative to other craft, as well as ground stations and rovers on the move. These radio beacons can also be used in space, helping with orbital maneuvers and guiding landers to on-target touchdowns on the lunar surface. Navigational Systems Engineer and Principal Investigator Evan Anzalone from NASA's Marshall Space Flight Center in Huntsville, Alabama, says the new beacon system will be like getting verification from a lighthouse on the shore rather than waiting for word to come from the home port you left days earlier. The new system's designed to operate as part of a broader navigation infrastructure, which will be anchored by a series of satellites in lunar orbit. Think of it as a moon version of GPS. Currently, navigation beyond Earth is heavily reliant on point-to-point services provided by NASA's Deep Space Communications Network, an international array of giant radio antennas in Barstow, California, Madrid, Spain, and near Canberra in Australia. They transmit positioning data to interplanetary spacecraft to keep them on course. These measurements are typically relayed back to Earth and then processed on the ground to deliver the information back to the travelling vehicle. But when seconds count during orbital maneuvers or among explorers traversing uncharted areas of the lunar surface, the new Lunar Node 1 concept will offer timely improvements. The CubeSat-sized experiment is one of 6 payloads included in the NASA delivery manifest aboard the Odysseus lunar lander, which launched last week aboard a Falcon 9 rocket from the Cape Canaveral Space Force Base in Florida. The lander is slated to touch down at the Malaport A impact crater, 300 kilometres from the Moon's south pole. Odysseus relies on network computer navigation software known as the Multi-Spacecraft Autonomous Positioning System, or MAPS. Upon lunar touchdown, the LN-1 team will conduct a full systems checkout and then begin continuous operations for a period of 10 days. NASA's Deep Space Network will receive its transmissions, capturing telemetry, Doppler tracking and other data, and then relaying that back to Earth. This report from NASA TV.
Lunar Node 1 is meant to be a demonstration of how we can use various navigation technologies to figure out where you are in and around the Moon. Some of the technologies here have begun as initial investment and technology developments when I first started here about 10 years ago. So it's been amazing to be able to see this technology grow from paper studies, software demonstrations, all the way up to a payload that are actually going to be demonstrating technology from the lunar surface. Our focus is on developing the enabling technologies to help vehicles and the science payloads navigate on, know where they're at, and know what time it is on the Moon. So part of our payload is demonstrate multiple approaches towards ranging, both through radiometric and also time-based delay measurements, in order to help vehicles understand how far away they are from some known location. That way they can help inform where they're at to guide their operations and navigate on the surface of the Moon. The Lunar Node 1 mass simulator. We use this build to test out our vibrational modes, put on a shake table, and also do fit checks with the lander itself. Inside of our payload, we have multiple electronics boards that fit within this chassis that is a little bit about a half U in size. Our external connectors where we have our data and power to the lander itself. And within here, we have multiple boards that do the power regulation, our data control, our FPGAs, all those kind of electronics pieces are in here, as well as a small S-band radio that attaches up underneath top radiator in order to distribute this heat and then to talk to the antenna.
And in that report from NASA TV, we heard from Evan Anzalone, Navigation Systems Engineer and Principal Investigator at NASA's Marshall Space Flight Center in Huntsville, Alabama. This is SpaceTime. Still to come, Equatorial Launch Australia releases the final designs for its new vehicle assembly facilities, which will be built at the Arnhem Space Centre east of Darwin. And later in the science report, we know that all dogs go to heaven, but which ones live the longest here on Earth? All that and more still to come on SpaceTime. Equatorial Launch Australia has released the final designs of its new horizontal vehicle integration facility buildings, which will be constructed at the Arnhem Land Space Centre east of Darwin. The buildings will be designed to handle a variety of different launch vehicle types, sizes and technologies. Current plans are expected to see up to 7 separate rocket companies using the launch complex for both orbital and suborbital missions. And so the new vehicle assembly buildings will need to be able to accommodate all different types of spacecraft. Current plans will see the assembly buildings being at least 40 metres long, 26 metres wide, and 12 metres in height, incorporating a range of features specific to different space missions. They'll each feature a large rocket assembly area, a high-clearance ISO 8 clean room for vertical payload integration, a full space overhead gantry crane, a large indoor workshop space, and a multi-port wall membrane for direct access to the launch pad equipment. The buildings will also boast substantial insulation, with HVAC climate control and cyclone rating to withstand the harsh Northern Territory environment. This latest announcement follows the release back in December of the final launch pad designs for the new complex. Current idea is that each space launch complex will include up to 2 launch pads serviced by a single vehicle assembly building. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. It's been revealed that a 63-year-old man has been in remission from HIV for 5 years now after he received a stem cell transplant to treat his leukemia. The patient needed a stem cell transplant to treat the cancer, so the team looked for a donor with a mutation in a gene known as CCR5. This mutation has been shown to be related to resistance to HIV infection. A report in the New England Journal of Medicine claims this case has now shown that older patients who are undergoing stem cell transplants for the treatment of cancer can also be cured of HIV-1 infection. The human immunodeficiency virus HIV is an infection that attacks the body's immune system, causing acquired immunodeficiency syndrome or AIDS. The World Health Organization estimates that up to 52 million people have now been killed by AIDS, with another 40 million currently living with HIV. A new study warns that Australian birds living on islands are among the species most at risk of extinction. The findings, reported in the journal Emu Austral Ornithology, are based on a first-of-its-kind study by scientists with the Australian National University. Australia has over 750 native bird species, but researchers warn that many of them are now facing an uncertain future, and the numbers are very sad. By 2020, 8 species were already considered extinct, and 10% more were threatened with extinction. Okay, we all know that all dogs go to heaven, but which ones live the longest here on Earth? Well, a new study published in the journal Scientific Reports has found that small long-nosed dogs, like whippets and miniature dachshunds, have the highest life expectancy, while male flat-faced dogs, such as English bulldogs, have the lowest. The team pored over data from 584,734 individual dogs from 18 different British sources, including breed registries, vets, pet insurance companies and clubs, and classified all dogs as one of 155 pure breeds or a crossbreed. After sniffing out various characteristics such as nose length, head shape and size, they found small long-nosed breeds had the highest life expectancy, living around 13.3 years. Or medium flat-faced breeds had the lowest at just 9.1 years for good boys and 9.6 years for good girls. Interestingly, the team also found that pure breeds had a higher average life expectancy than crossbreeds, 12.7 years compared to 12 years. While female dogs had a slightly higher medium life expectancy than males, 12.7 years compared to 12.4. A group studying people who claim to be able to talk to the dead through psychic channeling say they've been unable to find any definitive support for their claimed paranormal abilities. No surprises there. However, instead of dismissing their paranormal claims, the study's authors say channeling is likely to be very complex, a phenomenon that deserves far more serious study. Tim Mendham from Australian Skeptics says that's like assuming the claims are real and then trying to cherry-pick the data to find something that matches the claims, regardless of the real reasons behind it.
This story is full of red flags, okay? For a start, psychic channeling is sort of an offshoot or a subset of people who talk to the dead. psychics who talk to the dead, but any channelers are bringing through themselves often ancient spirits or people or whatever. But anyway, this recent study on psychic channeling, 2 red flags straight away. One of the main author of this study is actually from the Institute of Noetic Sciences. And the Noetic Science Institute is something that's been set up to look at the paranormal, look at sort of all sorts of strange psychic phenomena, etc., from the principle that these are believers. It was set up actually by Edgar Mitchell, the 6th man to walk on the moon, something like that. He had a big conversion about everything, actually. He became a very great proponent of UFOs and all sorts of paranormalities. Anyway, that's one issue. So you think, right, okay, the source of the author. Then the next thing about the thing is it's being published in what's called a Journal of Scientific Information, which is described as an open access, platinum peer-reviewed journal that is devoted to maverick or frontier science topics.
Peer-reviewed?
I don't know how well peer-reviewed it is. So they claim it's peer-reviewed. I'm looking at the website right now, and it's hard to see sort of how much peer-reviewing, because you don't know who peer-reviews an article, supposedly, or even how well it's done.
Well, these are his mates at the pub, I guess.
Something like that. This is a story, an article, research project that looked at a number of channelers, not many, to try and find out how well their prognostications, their readings of the other world compare when they're channeling and when they're not channeling. And I don't know how you tell the difference just when they're sitting there chatting to you, perhaps, and then when they're off talking with the spirits going through them. They often talk in strange voices because that's the spirit's voice. And so what happens is that they looked at these different things and they really couldn't find a lot of differences. They couldn't find any actual proof that these people were doing what they say they can do, that it was a channel, was a spirit talking through them. But nonetheless, they say this is a subject worthy of more investigation. They say that it's a complex issue, it's worthy of looking at, even though we didn't find anything. So it's probably influenced by many as yet unknown factors that should reveal much about the limits of brain functioning and human consciousness, which is not the words of an open-minded, I'm yet to be convinced researcher. They're talking about brain functioning, human consciousness, and unknown factors. The trouble is, nowhere do they say, are these people fakes? Right? They might say these people are misguided or they think they believe it. There's no evidence that what they do is true, and there's no discussion as to whether they're actually fakes. And that would be the common assumption by really open-minded researchers, is that first of all you've got to look at to see if these people are genuine channelers, which is a strange concept, and then you have to look at what they're saying accurate.
How could anyone prove that they've been talking to the dead?
Exactly right. Well, if the talking to the dead can actually say something meaningful, where is the money hidden?
Yeah, I guess so, yeah.
I mean, no one who actually contacts the dead, not the channelers, who just gets in touch with dead spirits and at a meeting and then relays the information to the relatives. No one says, I've got Uncle John and I hated you all your life. It's always sort of nice and sort of soft and sort of cuddly sort of words. The skeptics have investigated channelers for many years, and really, from a logical point of view, there isn't any, and from a technical point of view, to see what they actually say, it's always inane. These researchers have gone in with the basis that they obviously believe that channelers are real, and they just haven't found the evidence yet. But that's the wrong way around. You've got to look for the evidence to see if they're real, rather than assume they're real and then try and find the evidence to prove it. They keep talking about this doesn't match our hypothesis. It's not science, okay, but it's masquerading as science. And this journal that looks at, is a maverick journal that looks at the sort of fringe areas of pseudoscience, and the fact that they come from an organisation which promotes pseudoscience is not a good grounding.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.